Welcome back, everyone. In this lecture, we're going to talk about indexing and selection in NumPy. Specifically, we'll first talk about grabbing a single element, then expand this to grabbing a slice of elements. Then we'll talk about broadcasting those selections, indexing and selection in 2 dimensions, and then we'll talk about a very important topic called conditional selection, which we will also see a lot in Pandas and dealing with data and data cleaning in general. Let's head back to the notebook and get started. Alright, in my notebook, I've already gone ahead and imported NumPy as NP. Next, what I'm going to do is just create a simple array by saying NP arrange from 0 to 11 with a default step size of 1. So I have the numbers 0 through 10. Now let's imagine I wanted to just select a single value. To do this, I simply pass in the index, just as I would select a single value from a normal Python list. So if I just say 8, it grabs whatever is at index 8. So there we have the value 8. Let's imagine I wanted to get values in a range. I can do that the exact same way I can do this with a normal Python list with a starting position, a colon, and then an ending position, which will go up to but not including. So for example, if I say 1 colon 5, it goes up to but not including 5, starting at 1. So I get the numbers 1, 2, 3, 4. If I want to start at the very beginning, I can either say go from 0 up to but not including 5, or I can omit that 0 and say colon 5, which will basically say start at the beginning and then go up to 5. So these 2 cells are essentially the same thing. It's up to you whether or not you want to include that 0. Similarly, to go all the way to the end from a starting position, you can say starting at index 5, colon, and it will go all the way to the end. This is nice because that way you don't need to actually know how long your array is to index all the way to the end. Now, let's quickly discuss broadcasting. NumPy arrays differ from normal Python lists because of this ability to broadcast. With lists in normal Python, you can only reassign parts of a list with new parts of the same shape and size, and then you would also need to then possibly reassign this to a new variable. However, NumPy, you can actually broadcast a single value across a larger set of values. Let me show you what I mean by that. Let's take a look at our original array, the numbers 0 through 10, and then what we're going to say here is grab all the numbers from 0 to 5 and set that equal to 100. You would not be able to do this with a normal Python list. If you take a look at our array, notice now it's been changed. The values in the sections from 0 to 5 have this broadcasting reassignment. So 100 has been broadcasted across these values. Let's go ahead and reset this by saying np arrange 0 to 11. The next thing I want to point out is actually slicing a section of an array and setting it to a new variable will actually only act as a pointer to the original array. So I'm going to say slice of array is equal to my array from 0 to 5. So if I check out that slice of the array, then I get 0, 1, 2, 3, 4. And if I take a look at my original array, it's been reset so that it's 0 through 10. Now let's imagine I grab this slice of the array and I say just a colon to select everything, and I set that equal to 99. So now if I take a look at the slice of my array, everything has been set to 99 because I just set a colon here, which basically means from beginning all the way to the end. Now what do you think is going to happen with my original array? Well, with NumPy, that slice of the array was actually, when you assigned it here as array 0 through 5, you're basically just pointing it to the original array, which means this broadcasting operation has actually affected the original array. If you wanted to not have it affect the original array, you would need to explicitly set a copy. So you would have to do something like this. Array copy is equal to whatever original array, and then you call the copy method off the original array. And that way, you can do any sorts of changes you want to this array copy, such as grabbing everything and setting it equal to 100. And if you take a look at my array copy, that is now all 100s, but my original array hasn't been changed because of specifying that dot copy. Okay, so we talked about indexing and selection across just a one-dimensional vector here. We also talked about broadcasting. Next, what I want to talk about quickly is indexing on 2D arrays or matrices, and then we'll talk about conditional selection, which is a very important topic. To begin, let's go ahead and create a two-dimensional array. We'll say array 2D is equal to NP_array. And here what I'm going to do is simply kind of cast this quickly as a list by saying 5, 10, 15 as the first item in this list. Then we'll create another one, 20, 25, 30, and then finally 35, 40, and 45. So note here, what I essentially have here is a list of 3 lists. I'm going to transform that into a NumPy array of NP_array, and that will be my two-dimensional array. So now if I take a look at array 2D, I have this. So let's imagine that we actually wanted to just grab a single row. Well, indexing is basically going to work the exact same way in 2D, except now you have a dimension for the rows and a dimension for the columns. The first one is the rows. So if I say array 2D.shape, this returns back the number of rows first and then the number of columns. So at index 0 we have number of rows, at index 1 we have number of columns. That distinction is going to be important later on when we cover pandas. So let's imagine I wanted to just grab from array 2D a single row. Then I can pass in an index, so for example 0, and that will return back that very first row at index 0. If I wanted to grab the last row, well, for example, that's at index 2 because we're starting at 0. So that returns 35, 40, 45. Now let's imagine I want to grab a single element value from somewhere in one of these rows. Well, notice now I have this array, so I can index off that row array. So let's imagine I wanted 25. Well, that's at row 1, and then I could either index off of it with 2 bracket notation to then also say 1 to get 25, or what's more common is to just put this in the same set of brackets separated by a comma. So 1, 1 says at row 1, column 1. So let's go ahead and pick another number just to make sure we understand, like 15. That's in row 0 at column 2. We run that, and then we get back 15. Now we can also do the same thing, except expand this to slicing. For example, let's say we wanted to slice this little square of 10, 15 along with 25, 30. The way we could do that is simply by thinking of what rows we wanted first. So I want rows 0, 1, up to, but not including, at index 2. So I can say for my rows, go ahead and give me colon 2, which if we think about this, returns back rows 0 and 1, so up to, not including 2. Now let's imagine I only wanted 10 and 15, 25 and 30 from that. I could then say comma, and say something like starting at column 1, or column at index 1, which is 10, 25, go ahead and colon, go all the way to the end. And here we can see how we could grab that little subsection of our matrix. Now don't worry too much if you get confused by this sort of double notation. We really won't see this that often with real data sets. With real data sets, the rows stand for data points and the columns typically stand for features, so it's unlikely we need to do some sort of double subset. Typically we're either subsetting just on rows or on columns. It's quite unusual to do something like this, but you should be aware of that sort of notation in case it does come up. Finally, the much more common type of selection we'll be doing is called conditional selection. For this, we'll go ahead and show you an example. We'll say NP_arrange 1 to 11, and here's my array 1, 2, 3, all the way to 10. Now what I can do is I can actually broadcast a condition or a comparison off of this. So I can ask for, where is my array greater than the number 4? So I run that, and this returns back a NumPy array of Boolean values, where the index location matches up with the original data. So you notice it says false, 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 and then once it gets to 5, it suddenly becomes true, true, true. So what I could do is, showing you this in multiple steps, I could say my Boolean array is equal to array greater than 4, run that, and now I have this Boolean array, and I could use this to filter. So I could pass that in to my original array, run that, and now it will only return back the index locations of this Boolean array where it happens to be true, which is 5, 6, 7, 8, 9, 10, since these are all greater than 4. So again, the steps here I did was have some sort of original array, do a comparison operator, which gives you back this Boolean array, which you can then use to filter out your original array. Now I separated this out into multiple steps, but theoretically we didn't actually have to do this reassignment. So typically what we see is this sort of notation. We take our array, and then we ask for some sort of comparison, such as array greater than 4. Run that, and then we see here 5, 6, 7, 8, 9, 10. So this is the sort of thing we're going to be seeing quite often, especially when we move on to pandas. And pandas, we'll later learn, will give us the ability to then do something like multiple comparisons. So for right now, we just need to understand this basic idea that I can perform a comparison within my array and then pass that as my conditional selection filter. Later on, we'll discover more complex ways in order to do this for even more functionality. But for right now, we've discovered how we can actually index and select off one-dimensional arrays. We've talked about broadcasting, and then we talked about indexing and selection on two-dimensional arrays, and finally, this important topic of conditional selection. Thanks, and we'll see you at the next lecture.